In this video, we are going to investigate if there is a connection between increasing function or decreasing function and the derivative. Look at function f we are given here. So this function is an increasing function. Why? Because from left to right, the y value is getting higher and higher. So I claim that the derivative is positive everywhere on this graph. And why is that? Because if you draw a tangent line at any point, the slope of tangent line is positive, and slope of tangent line determines the derivative. Derivative at each point represents the slope of tangent line. Therefore, if f is increasing, then f prime is positive. Likewise, if f is decreasing, f prime is going to be a negative number. So let's have an example. Look at this graph. Okay, suppose that this maximum occurs at -1 and the minimum is at 3. So what happens from -infinity to -1? I'm going to highlight this. Okay, you see it. I highlight it with yellow. So from -infinity to -1, this function increases. Therefore, we can claim that from -infinity to -1, f prime is positive. Then look at the portion of the graph from -1 to 3. So function drops from -1 to 3. Therefore, the derivative is negative. So it means from -1 to 3, f prime is negative. And finally, from 3 onwards, that I made it green, function increases. Therefore, from 3 to positive infinity, function increases, which means f prime is larger than 0. So it means by looking at the graph of the function, you are able to say whether f prime is positive or f prime is negative. And what happens at these maximum and minimums here? Of course, at these points, the slope of tangent line is 0 because these two tangent lines are horizontal. Therefore, at the local maximum and minimums where the derivative exists, the derivative must be 0. I'm going to give you another example. Suppose that this one is the graph of derivative. This is f prime, and this is -3, and this is 2. Okay, look at this portion of the function from -infinity to -3. At this interval, f prime is positive. Why? Because the y value of f prime is higher than the x-axis. So therefore, we can claim that the original function f that we can see here is increasing. Next part would be from -3 to 2. As you see, from -3 to 2, f prime is negative. Oh, I forgot to write here from -infinity to -3, f prime is positive. So now from -3 to 2, f prime is negative. Why? Because it goes below the x-axis. Therefore, the original function f that we can't see here is decreasing. And finally, look at the green part. From 2 to positive infinity, again, f prime is positive, higher than the x-axis. Therefore, original function f is increasing. So these two examples clarify the connection between f and f prime by knowing that the graph of f increases, we know that f prime is positive, or by knowing that f prime is higher than the x-axis, we know that, for example, f increases. Next example is a given function with a certain equation, for example, x cubed minus 3x squared. We want to determine that at what intervals this function increases, at what interval this function decreases, and what are the local maximum and minimums on the graph of this function. So everything starts with the derivative, so we'll take the derivative and it becomes 3x squared minus 6x. Set it equals 0 and then factor 3x out, so it's going to be x minus 2 equals 0. So x equals 0 and 2. Then we'll make a table. So we write the solutions from the least to the greatest, and here should be f prime. Of course, f prime is 0 at 0 and 2. Now choose a number larger than 2 and put it in the highlighted expression, which is the derivative. So I want to know for x is larger than 2, what happens to the derivative, whether it's positive or negative. So if you try 3, obviously derivative is positive. If you choose a number between 0 and 2, like 1, it's going to be negative. And if you plug in x, a number less than 0, it's going to be positive. So it means function increases here. Why? Because f prime is positive. Function decreases here and again increases. Therefore, we can claim that from -infinity to 0, f prime is positive. Therefore, f increase. From 0 to 2, f prime is negative. Therefore, f decreases. And finally, from 2 to positive infinity, f prime is positive, which means f is a decrease, if f is an increasing function. So now I'm going to sketch the graph of this function to see everything is verified by the graph. The graph of this function is like that. As we discussed before in that table, see, from -infinity to 0, function increases. Then it drops from 0 to 2. Obviously here is 2. And then from 2 to positive infinity function increases again. So now I'm also interested to figure out what are local maximum and minimums to this graph. Okay, look at here when at 0, what happens at 0? Before 0, see, function increases. After 0, function decreases. Therefore, at 0 we have a maximum that, see, it is verified here. What happens at 2? See, before 2, function decreases, and after 2, function increases. Therefore, we have a minimum at 2 that you can see it exactly here. Okay, so let's summarize everything we learned today. If you want to figure out where your function increases or decreases, you take the derivative and make a table, and we'll see at what interval function the derivative is positive and at what intervals the derivative is negative. Also, if you want to figure out what points are local maximum and minimum, you set derivative equals 0 and you look at the table. If we have increase and then decrease, it's going to be maximum. If it's decrease and then it increases, it's going to be minimum.